Alright, we have this PDB file that we've downloaded, and now what we want to do is open that in a way that we can look at the text that's inside of it. So I'm going to right click on 1csn.pdb, and I'm going to scroll down to Open With, and you can use either WordPad or Microsoft Word will work fine. Just about any text editor will work, but Notepad doesn't work as well because it doesn't see the carriage returns as well. So you want to probably use WordPad or Word if you have those. Okay, so when we open it, the file actually has a whole lot of information. Not all of it's necessary for actually creating a molecular model in the different modeling software packages, but I'll go through some of the key components in the file. And you can always go to the pdb.org website, and they have a website that talks about all of the different parts of the PDB file that are possible, if you want to know what different things mean. But basically there's an introduction and a title section, an introduction section, a title section, then the primary structure, then anything that's not polymer. So if you have things like ATP or ions in solution that are non-standard, those will be listed. Then you have the secondary structure. Then there's some connectivity for any of the non-standard things that were listed. There's a section for miscellany. Then there's some crystallographic information. And then there's the main coordinate table, and that's the really important part. The coordinate table contains all of the atoms and amino acids that are part of the structure that you have in the file. And then the file ends with a connection table and some bookkeeping sort of file ending information so that the molecular modeling packages know how to deal with the file. Okay, so the introduction section is this header here. And then there's the title section. Within the title section, you can also have other things such as the compound that's in this, so it's casein kinase. You can have the organismal source listed. In this case, it's a fission yeast. You can have information about the journal and authors of the publication that first talked about this crystal structure. There can be a large amount of remarks about things such as the resolution of the structure. So in this case it's a 2 angstrom resolution. You can have other information. I'm just going to skip through this and get to the next section, which is the primary structure. So scroll, and we get to this where we see things that have SEQ as part of the keywords. And this is a list of all of the amino acids in the structure in order, left to right and down, given by their 3-letter characters. And then again we get to the het atom section. This is the non-polymer stuff where we have magnesium sulfate and ATP. We also have some water associated with this crystal structure, so those are listed as HOH. After the primary structure, we get into secondary structure. So we have helix formation with these leucines, valines, etc. And we have some beta sheet structure here. Then we have this connection table. This is essentially, for this structure, it's telling us that the magnesium has some connection to the ATP as well as to an amino acid in the protein. There's then the miscellany section. For this particular file, it's this section where we have the keyword site. Here is the section with the crystallographic information. That also includes the coordinate system and how large the coordinate system is going to be. And then we get to the really important stuff. This is the coordinate part of the PDB, and it lists the atoms of the polymer or protein, what atom number it is, so it goes 1, 2, 3, etc. through the list of atoms, what atom it is, so in this case nitrogen, the type of amino acid by its 3-letter character, what chain it's a part of, so if you have a monomer you will only have chain A, if you have a dimer you would have chains A and B, if you have a trimer A, B, and C, etc. This is the amino acid number in the sequence. In this case, the protein has been truncated. It's missing its first 5 amino acids, so it begins with amino acid number 6. We then have X, Y, and Z coordinates, so this tells us X, Y, and Z in our 3-dimensional space. And then there are a few other columns involved. These probably do have some meaning to whomever originally created this PDB file. These columns are not, the information that's stored in them is not critical for creating a molecular model. In fact, you can edit them in order to have some control over the way the molecular model is presented in different packages. So these are editable columns here. So we have a really long list. In this case we have 298 amino acids. So we scroll through the list until we see amino acid 298, which is a leucine. The polymer is going to be ended with a terminus line telling us that the line 2387 is the end of the leucine, that's the end of the protein, and then we get into our het atom section, which includes the magnesium, the sulfates. Those are what we would call residues 300, 301, 302. ATP here is residue number 299. We continue scrolling and we get to a section that includes, it's still the het atoms, but we have some waters here. So we have residue 400 through, let's see, through 502. So we have about 102 water molecules associated with this crystal structure. And that is the end of the overall coordinate part of the file. That's really important for the molecular modeling packages. And then we have a connection table that gives any non-standard connections between atoms. So this is just telling us that there's a connection between atom 1033 and atom 2388, whatever those correspond to in the list. And there's a large connection table here that would give that list of connections. And then, as I mentioned before, there are a couple lines, 3 lines here, that in the PDB file, that the master line is just for some bookkeeping, and this is an end of file line. And so that is the basic anatomy of a PDB file. I'm going to include a link to the Protein Data Bank website where they store all of the possible keywords and what they mean in a PDB file. And other than that, that's about it. The next video coming up is going to be how to load this and create a molecular model using VMD.